So in this video we shall see how to estimate the regression parameters in case of k number of explanatory variable regression models. So taking the matrix method, we shall discuss how to estimate the regression parameters. So as usual, to obtain the OLS estimates of betas, let us first write the k variable regression equation as. So our k variable estimated regression model is given as yi hat is equal to beta naught hat plus beta 1 hat, capital X1 I plus capital X2 beta 2 hat X2 I, in that way up to beta k hat xki plus ey hat. Now in matrix notations that we derived earlier, in matrix notations we can write in estimated form. Earlier we got y is equal to x beta plus u. Now in matrix notations, the estimated y can be written as y hat is equal to x beta hat plus u hat. Now we know the estimated, we always want the estimated error that becomes 0, so we are taking that u hat is 0. So actually we are getting y hat is equal to x beta hat. So this is our y, estimated y. Now if we represent your error term, e, then we know it is the difference between actual y and estimated y. So we are writing y minus y hat. Now substituting the values of y hat, we can write, because from here we get y hat is equal to x beta hat. Sorry. So yeah, our estimated error that we can write, it is y minus x beta hat. Now the residual sum of squares, if we get the summations and square over our error term ei, that is written as RSS, that is residual sum of squares, yeah, it can be written as in while discussing our assumptions of homoscedasticity and no correlation, then we takes that form of that error. So u hat transpose into u hat, or you can write u hat into u hat transpose, that represents our residual sum of squares or a summation of ei squares. So now ui hat, that we can write in that form y minus x beta hat, and u hat is y minus x beta hat. Here, as we are having the transpose, so we are getting the transpose here. Now taking the transpose, we can write y. So now it become y transpose minus beta x transpose into beta hat transpose, and we are getting as usual y minus x beta hat. Now if you get the multiplications of both the expression, then here y hat and y, then we are getting y hat into y minus y into beta hat x beta hat prime, or hat into x prime. So multiplication of these y with x prime beta hat prime or transpose, we are getting this value. Then we are getting multiplication of x beta hat with y prime, so we are getting this value, x beta hat with x prime into beta hat prime, so we are getting these values. So in that way, by getting the multiplication of both the expressions, we are getting these equations. Now writing in matrix form y prime or y transpose y and y transpose, that gives the same result. Okay, so minus here we are having beta hat prime x prime y, minus, just we have rewriting that equation, x is there, y prime is there, beta hat is there, result will remain same as it is in multiplication forms. So a into b and b into a, that gives the same result, so nothing to worry about that. Then we are getting beta hat prime x beta hat. So just we are rewriting or rearranging these equations for some manipulation. Now y prime, we are writing this same y prime or y transpose. Now you see, as beta hat prime x prime y, this matrices is a scalar, is in a scalar form, that is one row one column. So as it is a scalar matrix, single row single column, so transpose of this will give the same result. So we can write transpose of beta hat prime x prime y, that will gives us the same result here, y prime x beta prime x beta hat. So transpose of beta hat is equal to beta hat, transpose of x is equal to x, and y is equal to y transpose. So this value is equal to this value. So we can write these two are same thing. These two are same thing, as this is a scalar, that is one row single column. So suppose this is our scalar a. Now if you take the transpose of a, that gives also the same result. Okay, so from these two, as it is a scalar, so we can write here it is equal. So we can write 2 into beta hat prime x prime y, plus it is remaining same as it is. Now our objective is to minimize RSS with respect to parameters. So here parameters, that is our beta hat, so we have to minimize our residual sum of squares. So here the residual sum of squares, it have been partially differentiated with respect to beta hat, that is our regression parameters matrix. So having the differentiations of these, we can get the result. Now you know beta prime is equal to beta, or beta hat prime is equal to beta hat, so that gives the same result, because as it is a scalar. So we are having differentiation by simple differentiation. This is constant with respect to beta hat, that become 0, and this can also not be differentiated. So with respect to beta, this can be differentiated, but this cannot be differentiated because there is no beta. So here we are having beta, this can be differentiated with respect to beta. Here we are having beta square, so this can be differentiated with respect to beta. So from this part we are having that minus 2 x prime y, and differentiation of this gives us the result, that is 2 into beta hat x prime x is equal to 0. Now rewriting 2 beta hat x prime x is equal to 2 x prime y. Okay, we are taking this part on the left hand side and this part on the right hand side. So ultimately we will be getting that 2 get cancel. So beta hat is equal to x prime y by x prime x. Okay, so this is our estimated in matrix form. So in matrix notations, our estimated beta is equal to x prime or x transpose y divided by x transpose x, or we can write beta hat is equal to x prime x inverse into x prime y. So in earlier derivation we got that beta hat is equal to summation xi yi by summation xi square. So in matrix notation it is written as in this forms. So ultimately our beta hat that can be estimated. So first of all we have to calculate x prime x. If you get the transpose of x, and that resulted transpose form will be multiplied with x variables, and after getting x prime x, now you get the transpose of inverse of x prime x. So it is given by x prime x inverse, and then we get x prime y, and ultimately if you get the multiplication of both these two results, then we will be getting our estimated beta hat in matrix notation methods. So this is how we can estimate the parameters of general linear regression models by using matrix methods. So in our next class we will see what are the problems of multiple linear regression models. There the problems of heteroscedasticity that may arise, the problems of autocorrelation may arise, or the problems of multicollinearity that may arise, and how to detect that problem and how to get the solutions. So in our next video, one by one we shall discuss all these problems of multiple linear regression models. Thank you.